Hey everybody, it's Mr. Richards here, and the topic of the week is the particle model of matter. Now, after watching this video, if you're still confused, please send me an email or come to office hours and I'll help you out then. Now there's two vocabulary words that we really need to focus on in order to get to an understanding of the particle model of matter, and that is the words atom and molecule. Now, an atom is the smallest building block of matter. Everything is made out of atoms, all right? Now, the reason why we talk about atoms is because if you take an atom and you cut it in half, it's no longer that atom anymore. It's something completely different. So if I take an atom that is gold and I cut it in half, it's no longer gold. So an atom is the smallest piece, the smallest form of matter that is still that thing, that substance. Now a molecule, if this is an atom, one Lego piece, most simple building block, a molecule is just any two or more atoms that are bound together, all right? So this is a molecule, two atoms, all right? So we're going to move on and talk about water because water is a pretty simple molecule and it's easy to understand and talk about. So water is made up of three atoms. It's got two hydrogen atoms and one oxygen atom. And they're kind of shaped like this. All right? So we got three atoms here. Now, the reason we call this a water molecule is because it has two or more atoms, in this case three. They're bound together. And it's the smallest unit of water that we can get. And what I mean by that is if I take off this hydrogen atom, it's no longer water. It's actually something called hydroxide, which is way different than water. So when we're talking about molecules, it's the smallest unit of that substance that's still that substance, kind of like how an atom is the smallest unit of matter. So that's your water molecule. Now, I talked about water molecules and I talked about the atoms that made a water molecule, and those were hydrogen right here and oxygen. But there's way more of these building blocks than just hydrogen and oxygen. And if you pause the video and look at this chart, you might see some familiar names like silver or gold or aluminum or carbon. And these are all the different atoms that we know of, okay? Now the crazy thing is that every single thing that exists is made out of these atoms in different combinations. Now, even though there's only about 118 different atoms that we know of, we can combine different atoms in different ways and come up with completely new substances. So these are the most basic building blocks that make up all of the matter around us. Now, here's the important part, all right? It's important to understand molecules and atoms, but like I said before, we're really concerned with how these molecules are moving because this is physical science. So it's not super important for you to understand like what a water molecule looks like. It's more important for you to understand how a water molecule will move. For example, when it's in a liquid state or when it's in a solid state. So instead of drawing these water molecules out with two hydrogens and one oxygen, I'm just going to draw it as a single circle and I'm going to call it a particle. And when I say the word particle, what I mean by that is it's just a unit of water. In this case, this particle that I called water here, this circle, is representing this water molecule. Okay? That's why we call it the particle model of matter. It's just a way for us to understand how the molecules and atoms of matter move around. Okay, so that's pretty much your basic information, okay? I'm going to continue the video, and you can keep listening if you want to. I'm going to talk about a couple of other different molecules and differences between them, and if you're interested, keep watching. But this is the basic stuff. You can end here. So one interesting thing about molecules is that if you take the same atoms, all right, in this case, the atom that I'm talking about is carbon, only carbon, and I put that carbon together to form a molecule, in one way, it might be completely different than if I put it together in a different way. okay? And diamond and graphite are a really good example of this. Now, diamonds are one of the hardest substances that we know of, all right? They're pretty expensive. They're difficult to make. Usually we have to mine for them out of the ground. And graphite, which is the stuff that is in your pencil that rubs off on a piece of paper and allows a pencil to work. Now, like I said, both of these are made out of only carbon. Now, a diamond has the molecules put together in a really strong bond and a very strong shape. So kind of like if I put these Lego pieces together like this, very strong. Graphite is kind of weak, meaning that the atoms of carbon are put together to form a molecule that's a lot weaker. It's easier for it to break apart and rub off on the piece of paper. And that's really the only difference between diamond and graphite. It's kind of crazy to think about. There's some other examples of molecules here from common substances. So I think sugar is a good example because it is it looks like kind of like a sand type of structure. You know, it has grains to it. It's white in color. And sugar is actually a molecule that's made up of all of these different atoms bound together in this shape. Okay, this is a molecule of sugar. And all sugar molecules are going to look like this. All right. Now here's a caffeine molecule. Again, like any molecule, it's made out of atoms. And the caffeine, of course, is the thing that gives coffee its kind of kick. Now, coffee isn't made out of caffeine. Coffee is made out of hundreds of different molecules. But caffeine is one of the molecules that's in there, and that's what kind of gives caffeine its kick. Now, like I said, atom and molecule are kind of most important words to understand what our particle model is, but there's a couple more words here at the end. Remember, an atom is the smallest form of matter, so in our example, a single Lego piece. A molecule is any two atoms bound together, and our example of water is that a water molecule is the smallest unit of water that you can get. If you break a water molecule apart, it's not water anymore. Now, a substance is anything that is pure. So if I had just a water molecule, that would be a pure substance. If I have water molecules mixed with sugar molecules, it's no longer pure, okay? It's water and sugar. So when I say substance, I'm talking about one thing, either water or sugar, but not both of them mixed together. And pure goes along with substance. Again, something is not pure if it has more than one type of molecule in it. So pure gold would be 100% gold atoms. And gold is an atom, not a molecule. So only gold atoms would be pure gold. Now it's really difficult to get something 100% pure. So when we say pure gold, it's usually about 99.99% gold. So mostly gold. And then the last two are mass and matter. Now, I've talked about matter a couple of times, and matter is just anything that's made out of atoms, okay? Pretty much everything that you can see, you can touch, you can taste, that is matter. All objects are made out of matter. All things are made out of matter. And mass is just the way that we measure matter. Mass is just how much matter is in something, okay? Now, when we talk about mass, there's an important difference between mass and weight, because mass is the amount of matter that's in an object. Weight is how hard gravity is pulling on something. Now, if I stand on a scale on Earth, I'm measuring my weight, okay? But if I go up into space where there's zero gravity, I can't stand on the scale because there's no gravity to hold me on the scale. So I wouldn't have weight, but I'm still made of the same atoms that I was made of when I was on Earth, so I still have the same mass. And that's your biggest difference between mass and weight. Mass is how much matter is in something. Weight is how much gravity is pulling on something. All right? So that's your basic overview of what the particle model of matter is. And remember, we're just learning about atoms and molecules so that you can understand that when I show you a particle, so just a little circle of something, it's just representing molecules or atoms, because our job is to learn how particles, which are atoms and molecules, our job is to understand how they move around. All right? Again, if you're confused or you have questions, please come to my office hours from 2:30 until 4 o'clock every day of the week, or send me an email. Take care, everybody.